Okay, I will introduce my final report, which is mainly about the Atari Breakout game. And I have, uh, at first, I want to make the final report about different games, but at the end, I uh, focus most of the time in this Atari game. The first reason is that this game is not easy, that among many Atari games, this game is a hard one actually. And the second one is that we have learned the Q learning very like in the February. And at that time, I'm thinking about this game because last year I want to solve this game, and I used the ChatGPT and the cloud to write codes, the training codes last year before I attend to the reinforcement learning course. But I found that uh, the AI generated codes has a very bad behavior. And in my YouTube channel, I have uploaded the very earliest, you can see it's 3 months ago, and the behavior is very bad that it can only get like 20 score of 20. It's really not like a playing game. So I choose this topic as my final report. And when I when we learn the Q learning in class, and I realized that this game is a very this is a this is a tablet method can the game that use the Q learning can solve because the paddle, there are only uh you can suppose there are three actions, so the action space is not large. But actually the real problem is that the state space is very large. So the first stage that I set up a very simple version of environment. And in this environment, I largely simplified the state space and let the state space in about like 30,000. So I will show this. It's not this script, sorry. This one. So I set up the environment and the training together because this is a very simple environment. And the training is about like 10, 100,000. So this is the game environment, and I have put all the environment details in the report, and I will also share the codes in GitHub and also in the final delivery. And we can wait that about 1 minute. I will continue introduce. So at the end, you can see the game. When the environment is very simple, when the state space is not very large, you can see in this very simple environment, I use Pygame to create this environment, that it is really quite easy to learn the perfect strategy that can eliminate all the breaks. And you can see the strategy is not simply like let the paddle, the X be the same as the ball. No, it's just learn from uh, the all of them is learned, and you can see the reward setting is here that you can see in the report. Typically, it's not very complex. So this is the simple version, and actually the Atari game, the breakout in Atari game, like in about 8 years ago, the DeepMind has a very famous paper about a target game that we have also discussed on the class, that they use DQN solutions. So actually, I haven't learned the deep learning before this class, so I spent some time to know how to use deep learning and combine with the Q learning to use these deep Q networks. And the settings here are uh, almost mostly is the same as the settings in the paper that published by the DeepMind. And the problem is that most of the online resources of the codes They have shared code, but they are very early versions. It's the gene, which is operated by the OpenAI. And we all know that like 3 years ago, the open or 4 years ago, when the ChatGPT came out and the OpenAI stopped operating the gym, so now it is operated by the gymnasium, and so the environment settings are different. So this is the I think my work, my this final report, I will also share on GitHub, will provide an example of how to use the gymnasium V5 to use the DQN to train the game, to train this breakout game. And uh, so all the details are in the report. And I have, in my report, I will say that I have I report three circumstances, and the first one is about 200,000 iterations, and you can see that the reward is, this is the first version, it's in the code is this two, DQN end-to-end. So this provide the behavior is like the same as what I have showed the video that the code was last year was created by the ChatGPT, but this is the best reward, best performance. So I I let me see. So the next step is that I want to make it deeper. So I set a 1 million training times, and I uh, change some circumstances and parameters, and I use some AI tools to enhance my computer performance to, for example, add some checkpoints mechanisms. So in the 1 million, you can see that the behavior, the reward is steadily between the 30 and 40, and the peak arrives at 60. So continuing is the 2 million iterations, and you can see that the behavior is steady between the 40 and 80. The peaks arrives at over 100, and when it came into 6 million, and this training is start from the 2 million and use the checkpoint mechanism. So you can see in the output there are many checkpoints, and in this Atari checkpoint manager, this script, there is a mechanism of how to use the checkpoint to resume the training. And I have also write a evaluate script to evaluate the behavior of the model. And this evaluate script is using the 6 million, which is shown here, and we can see this. And we can see that the highest peak reached at above 175. This is amazing. And actually, the best behavior, so this is the model that we are using to evaluate the real behavior. And mostly it can reach the score of like 40 and 50, and sometimes it will reach the peak of over 100. And so let's see this game. One interesting is that when the ball became very fast, the behavior of this will be not bad. So mostly it can have a behavior between the 50 to 75, and sometimes it reached the peak of 175. So what happened when it reaches the very high level? So I have recorded one that can show this. You can see this one. So this is a very good example of why in some episode it can reach a score of like above 200 even. So you can see the ball is going to, the pedal makes the ball eliminate all the brakes in the left side. So there is a chance that the ball can go through into this tunnel and get into the upper side space. You can see when the ball go into the upper side space, then the ball will stuck in that space. So the score will be very high. So this is a very special condition. And in this training reward curve, we can see that I can, even though this behavior, this score is not recorded, but I can make sure that all the scores that is which are over like 150, the ball must go into the tunnel. It create a tunnel and the ball go through into the upper space to get a so high score. So it is amazing that the strategy seems like it found that when the ball can go in, create a tunnel, well, it can go into the upper space, it can receive a very high score. So you can see that this is not a very, very special circumstance or output, but it comes out many times, which means that the agent learns that there is a strategy which is going to create a tunnel, then going into the upper space and to make a very high level of score. So this is the breakout. And through this game, I think the most important is that this game is very classic. And I use this game from the very simple version that I create a Pygame version to use a very traditional Q-learning to a deep Q-learning that I found this game is still not ended. So which means I still need to spend more time on studying this game because the last version I have created several 5 scripts, and the last version uh, it really like spent me almost a whole month. So to reach this very, very good score that I have seen many uh, online videos that most they cannot reach this score, but I think it is still hard to let the agent know how to fully complete or completely win this game, like eliminate all the breaks. It might need more training times because the highest when this 2 million to 6 million, I use my computer to train them almost 3 days because a laptop is not very powerful, and the strategies, the algorithm also it has some space to improve. Like I see some online papers that introduce like double DQN or other strategies which can improve the training and make the experience or the uh, many details that is better. So this is my demo of my final report. Thank you.